Time permitting, I'd like to work a whole bunch of problems that all start with the notion of accepting the string 101 in an automaton. So we'll begin with that very basic problem, and this will form sort of a backbone or spine for a lot of the variants that I want to talk about. So if we want to consider a language that consists of a single string, then what we would want to do is to show that string in a series of transitions. So we'll go ahead and create a chain of states. And if what we want to recognize is the language 101, I will have a transition on 1, a transition on 0, and finally another transition on 1. And that defines our string 101 so that if we were to see that sequence of characters in the input, starting from Q0, we would wind up in Q3. Well, to say that we want to start at Q0 is to say that we want that to be our initial state for this automaton. And when we have seen 101, we would accept that, and so we mark that as a final or accepting state. And in a sense, that's all there is to accepting the language of strings consisting of the single string 101. We could actually leave it there, but I do want to point out that this is actually a little bit of a shorthand. And it's a shorthand because I haven't actually specified what happens on every possible input. We start in Q0 with no input considered at all. I have a transition here telling us what would happen on an input of 1. I haven't said what would happen on an input of 0. Now, I'm taking for granted in all the examples today that our alphabet is simply going to consist of zeros and 1s. It doesn't have to be, but we'll keep it that simple. But where do we go from Q0 if we see a 0? Well, let's introduce a state for that purpose. Now, if we get into this state, we know that since we have already seen a 0, this is not, no matter what else comes in the input will not be the string 101. So if we see any more inputs after reaching state Q4, for example, if we see any more zeros, we're just going to stay here. And if we see any 1s, once we've gotten into this state, we'll just stay here. This is an example of something that we call a trap state. And I'll even change the label to indicate that this is our trap state. A trap state is a state that once we get into it, we never leave, and indicates that no matter what additional input we see from that point on, we're never going to accept that. So if the goal of this automaton is to accept only the string 101, then we'll go into that trap state upon seeing an initial 0, and we'll never leave it. Now similarly, suppose we see a 1, and then we see a second 1. Well, then we know that we're not going to see the state 101. So again, we'll go into our trap state and say once we've seen 1, 1, we know we're never going to accept it, no matter what else follows in the input. And so we'll just stay here looping around in this trap state on whatever the additional input is, and there's no way to get from here to an accepting state like Q3. Or if we've seen 1, 0, and we see a 0, well, 1, 0, 0 is not 1, 0, 1, so we'll again go into our trap state. Furthermore, the string 1, 0, 1, 1 is not 1, 0, 1. So if we reach Q3, but there's still more input left, whether it's zeros or 1s coming up, either way, if we see more input than just 3 characters, we go into the trap state because that's not the string we wanted. So this is actually the full automaton for accepting the language consisting of the single string 101. Now, we often don't show the whole thing, but I know that this is the full automaton because I've said that my alphabet is the character 0 and the character 1. And you can see that in every state, I have defined what the transition is for every possible character in my alphabet. So in this case, every state here has 2 transitions coming out of it, although sometimes they're laid on top of one another, like this one, which is a transition on either 0 or a transition on 1. But I've covered both possible outputs from every state, and so I know that this is, in fact, a complete automaton. We often won't show this. We will often prefer instead to actually show it without the trap state and simply have it understood that whenever we have a state and we see an input character that is not given an explicit transition, that what we're really doing in that case is we're dropping into a trap state. So there are sort of 2 ways to say that we have not accepted a particular input string. One is a string like 10 that leaves us in a state like Q2, which is not itself an accepting state. So 10 would not be accepted. Or an input like 100, which takes us to here, and then we don't have a transition on the second 0. And so implicitly that moves us to the trap state. And again, we would say we do not accept 100 because we can't even name the state in this sort of abbreviated form of the automaton that we would wind up in on the input 100.